aging is more than just boosting NAD+, right? Like, we are a complex system, right? And you just talked about inflammation just a second ago. So how do we actually maintain liver function, right? Insulin sensitivity in the liver, insulin sensitivity in the muscle, these sorts of things that would potentially contribute to a loss of NAD+. So I guess we're just trying to say is, if you're just interested in boosting, which we're not, we're interested in boosting and preventing the degradation. If you're just interested in boosting, then yeah, you just take niacinamide. But we believe that there's an offensive and defensive role.
All right, folks, if you've been interested in this molecule everybody's talking about that seems to be kind of controversial, NAD or NR or NMN or whatever you want to call it, you're going to want to tune in to today's show, because I have a couple of guys who are really smart when it comes to this stuff joining with me to discuss all things NAD. So my first guest is Dr. Michael Roberts. He's a professor in the School of Kinesiology at Auburn University, where he directs the Molecular and Applied Sciences Laboratory and the Applied Physiology Laboratory. So basically, this guy has published over 180 different publications in several preeminent physiology and nutrition journals. He edits a lot of these journals. He presents at scientific conferences. And one particular area of expertise for Dr. Michael Roberts is NAD, and he's worked with companies like Compound Solutions and the International Protein Board, and kind of serves to advise a lot of these companies that are developing products that might contain something like NAD or NR or NMN, or he'll clear up the air about what all those different terms mean. My other guest, because this is a three-way, is Matt Titlow, who's the CEO of Compound Solutions, and they actually create and provide unique science-backed ingredients to different nutrition companies, including one called BioStack Labs, which I think we're going to mention in today's show. And so I've got some articles at Ben Greenfield Life that I've already written about NAD. I'll link to those. I'll link to everything else that we talk about in today's show. So all of the show notes are going to be at bengreenfieldlife.com/ingredients. That's bengreenfieldlife.com/ingredients, where you can also see the video of today's episode. So guys, welcome to the show.
Thanks for having us.
Yeah, thanks for having us, Ben.
Yeah, for sure. By the way, for people who are old school like me, listening to the audio, not watching the video, Matt, go ahead and speak up so people know your voice, and then Michael.
Oh, okay. Yep, this is me, Matt.
All right.
Yep, this is Mike Roberts.
All right, cool. Coming through my headphones, Mike's slightly louder and Matt's more soft spoken. So that's how you guys might be able to tell these guys apart. So who would like to take on the massive task of explaining exactly what NAD is and what it's doing on a cellular level? I realize that's a jam-packed question, but I'll hand it over to you guys.
Sure. I guess I can start, Ben. So, I'm sort of a molecular biologist by trade, and I sort of apply that set of lenses to exercise science research. But when you read like an ex-phys textbook, historically, you sort of appreciate NAD as an electron carrier. And as you know, cells, they need energy to function. And in order to harness the energy in cells, you need to have cellular NAD plus to carry electrons to the electron transport chain so you can eventually produce ATP in the cell. And that's kind of the main energy currency of all cellular biochemical reactions. So historically, I think people would view NAD as kind of this energy transfer molecule. A lot of interesting data has sort of surfaced, I would say, since really the early 2000s, right? So in around 2000 or so, researchers showed that, if you elicit nutrient deprivation, whether that's in vitro, like in a petri dish, or in rodents, this can increase longevity, and people started linking that to NAD plus levels increasing in certain cells or tissues, things like that.
Okay. And by the way, just to interrupt you real quick, if people say NAD, do they really mean NAD plus, like from a semantic standpoint? Because it sounds to me like NAD plus is the electron carrier. So is there a difference? Like when I'm talking about NAD, am I going to sound dumb hanging around with, smart guys like you if I'm not saying NAD plus instead of NAD?
No, that's a good question. We say NAD or NAD would be NAD plus, and then NADH would be the reduced the reduced form that's carrying the electron to the electron transport chain.
Okay, got it. So when it's carrying an electron, it's NADH, and when it's not carrying an electron, it's NAD plus?
That's correct.
Okay, got it.
Yeah. So since I'd say the early 2000s, and there's been a lot of names that some of your more educated listeners probably recognize, right? So David Sinclair at Harvard, Lenny Gorente at MIT, Charles Brenner, Shinichiro, these folks did a lot of work. And what they realized was that, hey, look, things like sirtuin activation occur through NAD plus. Mitochondrial NAD levels are linked to cell survival, mitochondrial function, and the like. Research since then has shown that certain DNA repair enzymes are called PARPs. They're activated by NAD plus.
And what's PARP stand for?
So that's a poly-ADP ribose polymerase, and it just aids in repairing damaged DNA.
Okay.
And so having this metabolite not only is critical for cell function through, energy transfer and ATP production, but then you talk about sirtuin activation, you talk about PARP activation, and these enzymes are also critical for cell survival, mitochondrial function, and the like.
Okay, got it. So we're not just talking about ATP production, or are we talking about the fact that NAD plus as an electron carrier, or NADH is the electron carrier, right?
Yeah, so the molecule itself is carrying the electron in the reduced form, NADH, that's going to have the electron to the electron transport chain.
Okay. All right. So when you're talking about sirtuin activation, PARP activation, some of the other functions that you hear about NAD supporting, is all of that just basically stemming down from NAD's ability to help the cell produce more ATP, or are those functions that are in addition to helping the cell produce more ATP? Does that make sense?
That's a good question, Ben. So it is in addition to, because NAD plus can act as a cofactor and interact with these enzymes in order to increase their activity.
Okay, got it. So even if it's not an electron carrier, even if it's not helping the cell produce ATP, there's other functions like some of these repair and maintenance functions that you're talking about that it's doing as well.
100%.
Okay. All right, got it. How come it got so popular? Because I interviewed Sinclair back in the day, and obviously some people even talked about how, I know he might listen to this show, so I'll be nice, but I think some people have said, he might have profit motives. Some people, are concerned about the whole, industry behind NAD just being all about making money, that we don't have to supplement with it. Like, what do you guys think spiked this whole interest in NAD? Because it seems to be very popular now.
Yeah, I guess I can jump in. So there's a few sort of milestone publications, right? Some of which was the energy restriction, linking it to NAD plus, and then that being linked to longevity. Since then, they've done a lot of different studies. We've done some studies, for instance, showing if we get a muscle biopsy from an older individual, and then if we get a muscle biopsy out of a younger individual, and we look at tissue levels of NAD plus, with increased age, you're going to show decrements in muscle content. There was a Minnesota study, I think, around 2012 or 2013, where they did MRI imaging of the brain. And so, obviously you get pretty pictures from that, but you can also do sort of metabolomics. And these researchers showed that brain levels sort of showed this incremental decrease with aging. And again, that would be NAD plus. There have been other studies. I think there was one in Australia showing that with skin cells, there's also this linear decrease of NAD plus with aging. So really what's capturing people's attention and imagination is, hey, look, with aging, we see this natural decrement, and it seems to be linear in this metabolite, right? Now you marry that with the fact that we know it can activate enzymes that are needed for cellular maintenance and repair. And again, that's a direct interaction of metabolite with these enzymes. I think it sort of makes sense that people want to increase, right, their NAD levels, be it through diet, exercise, lifestyle modification, or the like. So
yeah, that makes sense. It seems to me the surge in interest has kind of paralleled the surge in interest in anti-aging and life extension and longevity as a whole, which kind of makes sense if it tends to be as depleted as you're saying it is based on these muscle biopsies of older people. Is it the same, do you know, in men versus women when you're looking at these biopsies and the depletion that happens with age?
Yeah, that's a good question. My read of the literature seems to be it's not so dependent on sex. It just seems to be a function of aging, right? But what about other things? I mean, because, there's this comprehensive article that I recently released at Ben Greenfield Life. And again, I'll link to all this stuff. You go to bengreenfieldlife.com/ingredients, because we're going to talk about some different ingredients that could help to increase NAD in the body. But in that article, I talked about how some of the stuff I've seen that can deplete NAD probably come as no surprise to people, like alcohol or poor sleep or inflammation or insulin resistance. But are all of those similar pathways? And this might be kind of a loaded question, or are there different pathways via which each of the things that we know are depleting NAD are depleting it? I mean, is it just the cells getting beat up, or is alcohol doing something different than poor sleep, different than inflammation, different than insulin resistance, for example? I think you may have different mechanisms of action. And so, doing this with this line of research with Matt and other colleagues, I started my journey about 3 years ago, Matt, is that about right?
Yes.
And so I said, okay, to your question, Ben, why would we want to increase NAD levels? And then you quickly find, okay, it's linked to longevity. Got it. It's activating these enzymes. Got it. Okay. We know Americans, for instance, and really developed countries, they have poor diets. So is this because we don't have enough vitamin B3, which is a precursor, right, to cells making NAD? Is that the problem? And my read on the literature is it's not, at least according to the RDA. We'll get into that later, because it seems like if you supplement with, relatively higher levels of B3 or NR, whatever, then you're going to see this bump in NAD. But all that being said, I don't think it's, at large sort of diet, people not hitting the RDA. Does that make sense?
You think that the strip in NAD that we see with age is not because people aren't getting enough vitamin B3?
That's correct.
Okay, and so it would be some of these other reasons, like alcohol and poor sleep and inflammation.
So then with aging, what's going on, and I can speak to our own research. We published a study a couple of years ago, and we looked at young versus old. And I'd say old, it's about 60 years old. And we showed that muscle tissue NAD plus levels were lower, like 60% lower. Now, these people did not exercise, right? We then had them engage with 10 weeks of resistance training, and we showed a restoration to pseudo youth-like levels. So exercise certainly can affect it. We also looked at the enzyme in the muscle that's responsible for generating and maintaining NAD plus levels. It's called NAMT. And we showed that exercise was able to increase the levels of that enzyme. So that's where I think physical activity, and if you talk about aging and people just generally being more sedentary, perhaps part of the decrement in muscle at least is related to this decrease in NAMT enzyme content, right?
Okay, something important there, by the way, though. You said it was 10 weeks of resistance training.
That's right.
And then you said physical activity. Do you think it matters, like cardio versus weight training, when it comes to natural methods to increase NAD?
I think it's a conserved mechanism across both modalities, to be quite honest with you, because the only study prior to us doing that was done, it was out of ECU, and they were looking at endurance training, and they showed that endurance training can elevate muscle NAD levels. So there's some sort of conserved mechanism, and you see this with other things like myostatin. I don't know if you've ever delved into that can of worms, but myostatin's not good for muscle growth. Or whether you
I've Googled myostatin knockout bull and myostatin knockout dog and myostatin knockout mouse, and that Google image search result will show you some pretty good proof in the streets of what happens when you get rid of myostatin, and it is something that supports muscle growth.
And to be clear, myostatin, so far as we know, doesn't have any link with NAD, but that's just an example. If you look at something like myostatin, which is a protein your muscle produces, if you go out for a run or if you lift weights, there's a conserved mechanism where both modalities will downregulate the production of that gene and protein in muscles. So it seems to be the same with NAMT, which is the enzyme that's used to maintain cellular NAD levels, right? That exercise can affect that. I think a big thing, and Matt, you can hit on this, and we've talked about this, is inflammaging, right? We've all heard that term, and it's been thrown around a lot, and I don't like using it because really when you talk about the biomarkers to define inflammaging, you're going to get some differences in opinion there. But here's the deal, right? We know if you're getting older and you don't exercise and your diet's not good, and we take a blood draw, we're going to see the elevation in certain cytokines, right? Which are just proteins in the blood that are going to promote this low-grade inflammation because they trigger immune cells to produce inflammatory mediators, and that's bad for a variety of reasons. It can sort of depress exercise adaptations, right? There's been obvious cardiovascular issues in terms of atherogenesis and high blood pressure, this, that, and the other. There's metabolic issues with insulin resistance with low-grade inflammation. Well, with inflammaging, immune cells, they have a protein that's called CD38. CD38 is also a consumer, just like PARPs, and just like sirtuins. CD38 is a consumer of NAD+. And so with this inflammaging, you may sort of up the consumption of NAD levels, and that could be one of the reasons as to why, you see this decrease, not only with aging, but really we're talking about aging and poor lifestyle. Does that make sense?
Oh, it totally does. And I mean, there's this one political commentator I listen to sometimes. His name is Charlie Kirk, and he has this ad on his show where he says, yeah, I fly all over the country, and one of the ways that I've kept myself from feeling as though I've been hit by a truck, with however many hundreds of hours of flying the guy does, on a near monthly basis, he says, is I use NAD. And I thought that was interesting that I heard him say that. It's fresh in my mind because I think I heard him running that ad this morning. When I'm low on sleep, when I'm doing a lot of hefty airline travel, when I've been hit with a high amount of inflammation, even though I live a pretty clean lifestyle, NAD seems to help me out a ton. And so there's definitely something going on. I mean, even like lack of sleep or sleep deprivation seems to make a pretty good dent in that too. So it would make sense then, coming at it from the other way, that inflammation, whether it's from a poor diet or from airline travel or, high EMF stress or whatever, could be helped out by restoration of NAD levels, and inflammation could also deplete NAD levels more rapidly. Yeah.
Yep.
Exactly. If I could jump in, this is exactly why we're even collaborating with Dr. Mike Roberts at Auburn, is because at the end of the day, it's not about boosting. Because if we're just boosting, we just take niacinamide, NR, NMN, and be done with it. But it's about the NAD plus pools, right? Your status. It's about maybe preserving the declination, the decline, the degradation of NAD plus. So it's about playing offense and defense. For example, with that NAMPT enzyme, for example.
Okay, so offense and defense. When you're saying that, you mean taking stuff in addition to just vitamin B3, niacinamide.
That's exactly. Essentially, you prevent or you want to reduce the degradation while also, laying the foundation for a boost. In other words, do you want to just flood the system with NAD plus precursors? And we argue, no, you don't want to do that. That, it's almost like, hey, do you want to just take like a load of niacinamide and smoke a cigarette? Probably not, right? So anyway, This is what we're trying to do, is play offense and defense so their NAD plus status remains balanced.
Okay, I'm actually very interested in that, because I was with somebody I consider to be pretty smart in the whole nutrition and supplements industry a few weeks ago. We were walking on the beach, and he's like, Ben, like all these, NAD, NR, NMN supplement companies, they're crap. They're just making a dime. All you need to do is take niacinamide. That keeps your NAD levels restored just fine. Good old dirt cheap vitamin B3. What you're saying is that's just one part of the equation?
That is. And we're agnostic to that booster. Like call it niacinamide. For half of the equation, I agree with him. Right? So we're agnostic to whether it's NMN, NR, or niacin, even for that matter. And there's at least a study showing that they are boosting NAD plus at relatively equal levels. In other words, milligram per milligram.
Yeah. There was a study in 2020 from a Japanese group, and you can take all of these boosters, and you're seeing sort of the same thing. And Ben, to your point, right? You can just take the niacinamide, and it's a lot cheaper. But and I don't make a buck, by the way, on any of this. I just, full disclosure, right? Obviously, I've consulted with Matt, and it's more scientific advising. But as products go, they sell, and other people make money, man. So.
Yeah. Okay. So explain this to me just a little bit more about why I couldn't just take niacinamide, because you said you're boosting and you're, I think, maintaining the pools, or at least decrease the amount of degradation of what you're boosting. But what exactly is going on? And then would you say then, as a part of this, like ideal scenario, you take niacinamide, but then you also take some form of NAD?
So it is what we believe is that you take something like a substrate, right? Like a niacinamide, for example, but you're also working on the defensive side. You're trying to prevent the degradation. And that's like what we'll talk about later, probably, is like NAD3, which contains theacrine. And there are others, because aging is more than just boosting NAD plus, right? Like we are a complex system. Right. And you just talked about inflammation just a second ago. So how do we actually like maintain liver function, right? Insulin sensitivity in the liver, insulin sensitivity in the muscle, these sorts of things that would potentially contribute to a loss of NAD plus. So I guess we're just trying to say is, if you're just interested in boosting, which we're not, we're interested in boosting and preventing the degradation. If you're just interested in boosting, then you just take niacinamide. But we believe that there's an offensive and defensive role.
Okay. Yeah. I actually want to hear a little bit more about that offensive and defensive role. But before that, back to, I guess, what might be the offensive role. We've already named some things like sleep deprivation, inflammation, right. Too much airline travel, exposure to EMF, insulin issues with, probably a link to the diet from that standpoint. But what about ways you could naturally increase it? Because I've heard people talk about stuff like sauna, or, I think fermented foods was another thing I heard one time. But what are some ways that you would naturally increase NAD, or even things that you guys would do if you were to say, okay, I couldn't take any supplements at all. How am I going to keep NAD up?
I think the big one is what we hit upon earlier, and that's exercise. I mean, no question, right? So if you want, Ben, I can send you the article. You could put in your show notes, or
for sure.
It. But in older individuals, which again had around 60% decrements in muscle NAD levels relative to college age individuals, just 10 weeks of training, and that was total of 20 training sessions, it restored those levels. And we thought that it operated through that NAMT enzyme, which is part of the salvage pathway that keeps NAD levels relatively higher. So the big one is exercise, to be clear, right? The other is, I did a little bit of digging into alcohol consumption. There's a guy at UCLA by the name of Sam French, where he's proposed, in rodents at least, that high blood alcohol levels, which are experimentally induced, will lower liver levels of NAD+. So nothing wrong, obviously, with the occasional drink, but if you're binge drinking all the time, probably not good for the liver NAD+ levels, and that may trickle down to other tissues as well, right?
Right.
Yeah, I'm glad you brought that up, too, that you mentioned binge drinking, because most of the studies I've seen on the deleterious effects of alcohol involve an amount of ethanol that would cause someone to become near inebriated. I don't know a lot of health enthusiasts who are doing like a little bit of bitters or a nice digestif, like, I've been on a Croatian Palenkovac kick lately, or, Ebo Libo from Italy, like or wild crafted, herbs and plants and bitters that have a little bit of alcohol added to them that, I'm serving over sparkling water with a little bit of lemon. That's way different than like, a couple of 6-pack of beer on a Saturday night, or going through like 3 fishbowl sized glasses of wine on 3 different nights of the week when you're stressed out. Like, I really think we have to not use baby talk when it comes to alcohol and have it be black and white, yes or no. I think the dose, of course, is the poison. The delivery method is the poison. And, I personally use NAD and I drink alcohol, but I highly doubt that even like my type of alcohol consumption is stripping my body's levels of NAD that remarkably,
Agreed.
Yep.
Agreed.
So yeah, those are the big ones. And then, you talked about sleep deprivation or jet lag or what have you. I've seen a little bit of literature, and I can't recall any of the authors, but I looked into that. And that's a bit of a chicken or the egg thing, because I know they're trying to use boosters to perhaps restore sleep. But does sleep cause deprivation? So I think there's a little bit of science to be parsed out there.
Yeah. Okay, that makes sense. But by the way, have either of you guys ever been sleep deprived and just taken a bunch of NAD? Like whether it's I know, Matt, you make or you're involved with the cell regen stuff from BioStack Labs. That's one that I've taken like a double dose of on a sleep deprived day. Have either of you guys actually done that?
I've been sleep deprived, but I have not. I have 4 kids, very young.
Yeah.
So,
yeah.
Always sleep deprived.
Yeah. Yeah. I think we need to try that in your household.
Yeah. You do. That's actually my stack for sleep deprivation is creatine and NAD. And creatine, they've shown that slightly higher dosages for brain function and sleep deprivation, like 10 to 20 milligrams. And then, even though I don't know the exact dosages on NAD, usually I just throw in a couple of extra capsules. It is a game changer to stack NAD and creatine on a sleep deprived day. Like it's literally almost shocking the amount of extra willpower and brain power you get just from that stack alone.
Yeah, that's interesting. And this is kind of a left turn, but I've been involved with a lot of creatine research, and we're showing brain, at least in the rodent model, and there's some human studies too, that creatine is good for the brain. But like you said, you probably higher doses. So you typically hear 5 grams per day is kind of the maintenance dose or whatever. But folks like Darren Candow, Scott Forbes, those guys would say, hey, man, let's go 7-10 grams per day to get these added benefits to other tissues besides skeletal muscle. So, yeah.
Right.
Yeah. Yeah. Now, Michael, I think you were saying there's not a huge difference between supplementing with NR or NAD or NMN. Like, let's say you're already using a little bit of niacinamide as you've recommended, and then you want to keep levels up, like playing that defensive strategy. Are you saying it doesn't really matter if you use NR or NAD or NMN?
Well, so to be clear, I've not done those studies, right? But there was a recent study from Japan in 2021 that did the head-to-head comparison on, I believe it was NR, it was niacinamide, right? And Matt, help me out there. There was
I think it was NMN.
NMN, yeah. And they showed that it was like 5 or 6 people. So caveat being that it's relatively limited in scope, but looking at serial blood draws post-consumption, that you would see the same response in the blood with NAD plus levels. So based on that, so far it seems like all cause the same effect when it comes to boosting the metabolite. But buyer beware, right? I mean, research, it takes years to sort this stuff out. So I think we need a little bit more research to hone in on that because of the limited scope and end size and that sort of thing.
Yeah. What do you think about that, Matt?
I think, so far it seems to be equivalent. So I don't believe that there's a big difference at this time between the three.
What about NAD3? Because I think that's originally how I hooked up with you, Matt. Was I interviewed I interviewed Tony Robbins and Pierre Diamandis, and those guys were like, "Dude, you got to check out NAD3. It's one of the best ways to keep levels boosted with oral supplementation." Later on, I connected with BioStack Labs, who was making this cell regen product that has the NAD3 in it, and I think you've helped them out with that product. But what's the deal with NAD3?
So this came about from me and the late Dr. Hector Lopez. I don't know if you knew him. A brilliant individual, and he was connected with Tony and Peter, etc. And so I went to Hector with an idea. He and I went back and forth, and then came up with NAD3. And then he involved his partner, who we are still partners with, Tim Ziegenfuss, Dr. Tim Ziegenfuss, and also I'm involved with Hector Lopez's wife, Yari Lopez. So what we were thinking is, okay, how do we again play a little bit of offense and defense, right? So on the defensive side, we went to Mike and said, hey, let's just study this at a cellular level. And what we found is what Mike just said earlier, which is an upregulation of the NAMPT enzyme. So just like exercise keeps that, let's call it healthy or functioning. And that is what is converting that substrate, call it niacinamide, to NAD+. This is what we're finding, is that NAD3 is upregulating that enzyme. So when you have that substrate, it converts, call it niacinamide in the blood, for example.
Okay, so NAD3 is upregulating the NAMPT enzyme, which is allowing for the conversion of something like niacinamide into NAD?
That's exactly, yes.
Okay, and what is NAD3 exactly?
NAD3 is made up of 3 ingredients. One is theacrine. Theacrine is a methyl urate. It looks very structurally similar to caffeine, but it has different action. So its different action is mostly, believe it or not, as a dopamine agonist, as well as some lipid metabolism, like in the liver, right? So kind of liver and dopamine is kind of its action. It also contains, NAD3 also contains wasabi.
You mean like wasabi, spicy pea wasabi?
Exactly.
Okay.
Yes. And the third is a copper 1. So it's reduced form, the bioavailable form. And I can go into why, if you would like, but that's the makeup of the NAD3 molecule.
I want to know how those things work. So it's wasabi extract, theacrine, and what was the last one you said?
Copper 1, cuprous niacin.
Copper 1. Okay, so why those 3?
So what we were thinking, this is me and Hector early on, I said, hey, what about, theacrine for kind of like the anti-inflammatory action, kind of like SIRT3 activation. So think of liver function, lipid metabolism, this sort of a thing, kind of like a healthy aging on the anti-inflammatory side, the defense. But I said, well, aging is more than that. It's mitochondrial function. What about, copper? There's a depletion in soil over the last 50, 60 years for obvious reasons. And then he's like, yeah, that's cool. But what about something like wasabi, like broccoli, these things that have isothiocyanates, these, help with antioxidant status and more. So it was more about addressing multiple hallmarks of aging versus just saying, you know what, let's reduce all of aging to NAD plus. We all know that's not rational. So it was about trying to take 3 of these ingredients, combine them together to have, to conquer like 7 pillars of aging versus just 1, for example.
Okay, that makes sense. So those 3 are working in combination. When I'm looking at the cell regen label, though, you've got niacinamide, 125 milligrams of niacinamide. Then you have this NAD3, which makes sense. The wasabi extract, the theacrine, and the cuprous niacin. Right. Then there's resveratrol, spermidine, and black pepper extract in there. Why'd you add those in?
Right. So that's a biostat question. But if you are looking at, resveratrol, that's obviously extremely famous. People know that from years ago from Sinclair and sirtuin activation. But, also keep in mind that Mike was saying earlier that sirtuins, are consuming NAD plus. Right. So, having that substrate in there, like a resveratrol, is a nice way to preserve NAD plus status without it being consumed. Right. And then when you add in something like a spermidine, we call it youth. You're looking at another pillar of aging, autophagy. So we can go into that if we want to, but I don't want to talk too much. But the bottom line is looking at various pillars of aging and why each of those combined into something greater than each of its individual parts.
Yeah, I've done podcasts on autophagy before, the cellular cleanup, and I think a lot of my audience gets it. And I've talked about spermidine before as well. I was just curious the reasoning behind throwing those in there along with the NAD3, but it seems like a good formulation. It also kind of makes me think a little bit about whether or not you could do this too much. Like I used to know one doctor, and he told me that he only takes NAD 5 days on, and then he takes 2 days off because he doesn't want to overload himself with NAD. And then I came across this study by Nicola Conlon that somebody forwarded to me. And the study, and I'll link to it in the show notes if you go to bengreenfieldlife.com/ingredients. It's called A Systems Approach to NAD Restoration. And in that article, she goes into the idea that if you have excess inflammation, that too much NAD could be bad for you, or that if you're, I think the other argument in there is that potentially if you have poor methylation status, it might also be bad for you, which I thought was interesting because a lot of people who get NAD IVs feel better if they've taken methyl donor prior, like trimethylglycine or SAMe or something like that. But what are you guys' thoughts on this idea that, too much NAD can be bad for you?
I can take a stab. So, right, if you just look for the magic pill and then you don't change your lifestyle, right, and you're sort of still susceptible to this inflammaging thing. I mean, you are providing, right, if we take the niacinamide, we boost the NAD plus in cells. Oh, but then by the way, right now we have a substrate for something like CD38 to consume it and propagate inflammation. That's where I think you can perhaps see a little bit of trouble. That's hypothetical, and I haven't read into that. I mean, the only study, I found a very intriguing research article from the Buck Institute where they had developed mice that didn't have the CD38 gene. And then they showed, feeding with precursors clearly had a conferred benefit. Not sure if they looked at any sort of secondary inflammation status, but point being that, right, we have a clear link. CD38 in immune cells can use this as a substrate that can promote inflammation. You can even search PubMed or Google Scholar, and you can see this link between like inflammatory bowel disease and people making the argument that substrates for that, being NAD plus, could sort of exacerbate that process. So I'm always a big proponent, and I preach this in classes, on podcasts, right? I mean, supplements are what they are, and that is we're looking to enhance, but we're not looking as the supplement to cure, the ailments that you may or may not have. And that really starts with cleaning up the diet, not drinking as much, not smoking, to Matt's point, and certainly consistently exercising, once you get into that, in my opinion, once you get into that routine, then from there you start really tinkering with supplements, because you've established a nice baseline. Does that all make sense?
Yeah, and also based on my understanding of that paper, especially if you have some genetic methylation issues, not only kind of stopping up the leaks of inflammation if they exist prior to starting into hefty NAD supplementation, but also addressing methylation issues like getting really good bioavailable folate, avoiding supplements that might contain synthetic folic acid or cereals and grains fortified with synthetic folic acid, and even considering something like, organ meat or liver consumption to get really bioavailable methyl groups on board. That my takeaway from that paper was, don't start taking a bunch of NAD to band-aid an issue. Instead, use that to support your body, but address inflammation from a wide variety of sources, and then make sure that you test and address methylation status.
Well, and here's a little secret, Ben. So, we wear a lot of hats, and some of the stuff that we do is just we want to look what exercise does regardless of supplementation. And we worked with a researcher that's really good with DNA methylation arrays. We had people lift weights, and we took biopsies like hours afterwards. Exercise can vastly and robustly affect muscle DNA methylation. We did another study showing with aging, for instance, you're going to have mitochondrial DNA in muscle. It is hypermethylated. And that when you exercise, and these are older individuals, but you promote chronically this hypomethylation so that you can have mitochondrial DNA replication, you can have mitochondrial DNA transcription to, make eventually the electron transport chain protein. So again, it comes down to I think exercise is first. And I mean, clearly conflict of interest, right? I'm in the School of Kinesiology.
Yeah.
But you have to really view these things from the lenses of, hey, we need to get physically active. And then from there, how can we support the system, right?
I'd also like to jump in and say, didn't you study when you were studying NAD3? We obviously found that it didn't hypo or hypermethylate, right? It was quite balanced. But didn't we look at another NAD plus precursor, and it was hypermethylating?
Yeah.
In other words, to Ben's point, you can overdo it, I guess, to Ben's point, right? So exercise may recover that.
Yep.
But that was something that we actually did to make sure that we were not hypermethylating, but you could, because we actually tested and it did. It's another.
And so just for the listeners, the study we did, and this was in collaboration with Tim Ziegenfuss and late great Hector Lopez, but there was a placebo group involved, and there was NAD3, and then we have a little bit of preliminary data with NAD3 plus a precursor, but we're still sort of analyzing that. Long story short, we put out sort of the early work with just placebo versus NAD3. Groups. These are humans. We had baseline sort of pre-intervention blood draws where we isolated the PBMCs, which is, immune cells, for lack of a better term, from the blood. And then after supplementation, which was 12 weeks, we again took those cells from the placebo and the NAD3 group. And we did DNA methylation arrays, and we saw less erratic methylation. Now, what does that mean, right? So over the intervention, there was less hypermethylation of the DNA in these immune cells, and there was less hypomethylation relative to the control group. So that's interesting. The other thing we did was we did a technique that's called transcriptomics. So you can look at all of the messenger RNAs that are being expressed in those cells. There were a lot of them. There's not like one or two I can say, hey, these are critically important. Some were affected in a positive light that were related to DNA repair. But when you take this list of differentially expressed mRNAs through the intervention between the NAD3 group and the control group, and you do sort of this in silico technique on the computer, saying, okay, this basket of mRNAs, what does this represent? There were a couple of things that I thought was really interesting, one of which was we see this reduction in ER stress, and that's potentially because it's predicted through these mRNA signatures, right? So
You mean endoplasmic reticulum stress?
Reticulum stress, that's right. Yeah, sorry. So endoplasmic reticulum stress, which if it becomes dysfunctional with aging, that can cause cellular apoptosis, cell damage, and the like, right? Mitochondrial damage, you name it. So that was interesting. Another one, which I was like, what's going on here, is that the mRNA signature NAD3 versus control with that intervention was predicted to lower mRNA transcription in these cells. So I thought initially, this is not good. we need mRNA transcription, right? Just for the cell to function. We'll come to find out, did a little bit of digging there. And this is like 2023 science, but aging researchers are saying one of the reasons why cells may age is that we have sort of this aberrant and uncontrolled mRNA transcription. It's almost like this situation where there's not tight regulation, and so we have too much mRNA transcription. So again, found that interesting. Can I link an ingredient in NAD3 to that effect? That's what we're continuing to do with Matt, right? Is saying, hey, let's go back to the drawing board. Let's do this in vitro. Let's see what's going on. But this is part of what Matt's talking about, which is, lowered inflammation. Another thing was improved blood lipids, and we thought that operated through the liver. And then third, using this PBMC model in humans, we're seeing unique gene expression signatures, which are leading us to the next step in terms of research. So,
yeah, that makes sense. What about the idea that, what's it called, a tachyphylactic response when you start to get used to something that you're taking, which I think might also be a reason that doctor was telling me he goes 5 days on, 2 days off with his NAD supplementation. You think there's any reason for that? You think that the body can get used to oral NAD supplementation? Like any feedback loops or anything like that you guys have heard of?
Are there feedback loops? I'm not aware of any data on feedback loops. Can you consume too much? Researching just the precursors alone, if you go to like the NIH's website for the Office of Dietary Supplements, right? Once you start getting to pretty high doses, so we're talking about over a gram per day, you can have side effects like GI distress. Certain liver enzymes are actually elevated in the blood, which would indicate that you have, tissue damage. You can certainly have hypotension and things of that nature. So I think, yes, you can take too much. Like people that are enthusiasts and like, hey, NAD plus, we need to boost that as soon as possible. Let me take double, triple the dose. Not a good idea, in my opinion, with the precursors. In terms of these defensive mechanisms, right, what Matt's speaking to, we just don't have the data, to be quite honest. I mean, I think that's an interesting area of study, but what I can say is based on the human work we've done, we didn't see any of the sort of clinical signs of like tissue damage. When you get blood draw at the doctor's office, for instance, you get a lot of tissue enzymes that would indicate as to whether or not you're seeing, muscle damage, liver damage, kidney damage. None of that stuff popped off the charts over a 12-week study. But, I don't know, Matt, what did you want to add to that?
No, I agree. I think, over consuming is really a good idea. Yeah, what you said. Over consuming is just not a good idea.
Yeah. Well, the other thing that obviously people do massive doses via IV. I've done that before. I've done many NAD IVs. I've probably done close to 50 of them over the past maybe 7 years or so. And, that's 1,000 mgs, sometimes 1,000 mgs plus. I've talked about this before on my podcast. I've used NAD patches, like to do the slow delivery of 500 to typically like 800 milligrams transdermally. There's one company called Ion Layer that makes those. I've even done NAD suppositories. Like I've done that for like long haul plane flights before. There's one company called Mitozen where I've gotten NAD suppositories. What do you guys think of some of these alternate routes of NAD delivery, whether it's IV or transdermal or rectal? Have you guys messed around with that at all? Do you have any opinion on it?
Matt?
It feels over-engineered. you know, I'm not like necessarily against it. What I'm just thinking to myself is, if that study that Mike mentioned from 2020 showed NR, NMN, and niacinamide increased NAD plus, then why are we taking it rectally or IV or, you know, anything else? Or if you can exercise and keep things, you know, balanced, or you can take like NAD regen, why? You know, it just feels over-engineered, I guess is my point.
I don't know. The claim I've heard is better cellular uptake when you bypass oral administration, you know, that type of argument.
Yeah. But I guess it's like creatine, you know, it's already bioavailable. Do you want it more bioavailable? I guess how much more bioavailable is that? Like, is that oral administration? So, like, let's say lacking in bioavailability to the point where you're not boosting or feeling well. Well, then obviously you go that IV or rectal route.
Yeah. Yeah. Well, I think originally, like a lot of the IVs were used for, like addiction and detox. And maybe it's just because that high of a dose, as you were talking about earlier, Mike, wouldn't be that well tolerated orally from a gastrointestinal distress standpoint. I mean, maybe that's why if certainly higher doses might help with detox or with addiction, you know, that type of thing, that maybe the IVs were favored by a lot of these functional medicine doctors and then later picked up by the biohacking community, but originally just because you can't take that massive dose without gastric distress, you know?
Yeah, and the one thing to consider too is NAD plus itself, to your point, you can't orally ingest it. It's not going to be bioavailable. And two, it's tricky to get it's not, so it's not fat soluble, right? It's not going to just diffuse across a cell membrane, and transporter wise, there's not a good transporter system to get it across too. That's why you take the precursors. So the precursors can get into the cell, and then the enzymes can use it to make NAD plus. So,
to Ben's point, is that it? Is that you might take it just because, let's say you're inflamed, you're not exercising, and you don't have the NAMPT enzyme to be converting. And, you know, so to Ben's point, it is lacking in bioavailability orally because you don't have the mechanism because you're inflamed, let's just say, and an IV is direct.
Yeah.
Mike?
And I think this sort of speaks to, I'm not trying to talk over you, Matt, but I think I'm trying to loop in my thoughts to what you're saying, which is, and you brought up creatine. I think that's a beautiful example. Hey, man, look, creatine monohydrate works. Everyone's excited. Now, how can we improve? How can we improve? How can we improve? And so we sort of go through this as a research community, as a nutritional supplement, you know, marketing standpoint. There's sort of this long march towards let's improve delivery. Let's improve bioavailability. Let's inject. Let's do this. Let's do that. But really, it's like, look, man, creatine monohydrate works. Should we have stopped there? You know?
Yeah.
Is there a point of diminished return? Is there a point of, you know, so, I mean, these are things that you have to consider when you're thinking about this stuff. And to Matt's point, you know, so far as we know, just a niacinamide on the offensive side seems to be plenty good. I don't know if we're going to get into it, and I don't know much about it, but like NMN, which is another precursor, right, was a supplement. No longer a supplement because the pharmaceutical companies took interest in that. And so, just niacinamide and,
yeah.
And
well, you just shot down my idea for preloaded syringes full of creatine monohydrate that you could ship out to somebody's house, you know, insulin-like injection. Thanks a lot for that. But that thing you just mentioned about the pharmaceutical industries is interesting. I saw that. Like, you can't get NMN anymore. So what exactly happened?
Matt probably knows more than I do on that front.
Yeah, apparently some pharmaceutical companies said that they had filed an IND and, you know, prior to becoming a supplement, and pharma won, you know, so far. That's essentially the short story.
So you think there's going to be some pharmaceutical coming down the pipeline that's basically really overpriced NMN that you could get covered by insurance or something like that?
Word. Yes.
I'm shocked.
I know.
First time business, man.
First time ever.
Yeah, I know I'm spitballing a few random questions at you guys, but this is another thing I've been wondering about. I find NAD very stimulating. Like I mentioned, I've been taking the biostacked cell regen stuff that you helped to formulate, Matt. And if I take that at night, I'll have a hard time sleeping. Same thing if I'll do like a NAD suppository on a long haul flight. I don't sleep so well. It's almost like too stimulating. Have you guys ever seen research that looks into circadian rhythmicity in NAD, or even just the best time of day and way in which to take it, like with the meal, without a meal? Like, what's gold standard if you have this stuff as far as like how to dose it and time it?
Matt, any thoughts on that?
So I was thinking first I was thinking about within NAD3 is theacrine, which is a dopamine agonist. It also has been shown, to elevate like mood, focus, and energy. Almost like, remember Hector used to talk about allosteric modulation, essentially like it's a slight adenosine inhibitor like caffeine is, but it's a light one. So I think between its like light adenosine inhibition, it's dopamine activation for like mood motivation.
Right. And since adenosine increases sleep drive, that might be why if I take, the BioStack lab stuff too late in the day, it might be overstimulating for me.
It could be, particularly the dose that you're taking. You asked a second question, which was, I lost it. Pardon me. It was,
when do you take it with a meal, without a meal, morning, afternoon? Like, has there ever been any research on that?
No, I would just be surmising. Any thought, Mike? If you want.
Yeah, and I'm trying to think back to the 12-week study we had done in the humans. I want to say it was in the morning, and I also want to say that it was taken with breakfast, but I'll have to check.
Okay. As a general rule, I would just take it in the morning, generally speaking.
Okay. God, have either of you guys done the IVs? Like, just seeing what that feels like?
No, I need to come over to your house, apparently. I have a feeling it's like decked out. I feel it's decked out.
I did a 1,000 mg push IV of it once in about 11 minutes with a garbage can next to me for the overstimulating gastric distress. But normally, it's like a 2 to 4 hour sit with the drip IV. And even then, unless you're taking methyl donors, like trimethylglycine is probably the most popular one beforehand, you still have a pretty large amount of butterflies in your stomach when you're doing it. But I feel this, and a lot of people do as well. Like, you feel pretty unstoppable for a few days after that massive of a dose of NAD via IV. But
you have to take it with TMG, with betaine, you're saying?
If you want to stave off some of the almost feels like excess sympathetic nervous system stimulation during, might be, I don't know, depletion of methyl groups or poor uptake or what, but a lot of doctors co-administer a methyl group along with it.
Well, there we go. From the prior conversation, or just a few minutes ago, is you're an N of 1, but maybe that's it. Is that you hypermethylate on overconsumption of NAD precursors and just take betaine with it if you want to go big.
Yeah, that's interesting. What about any new research happening on NAD as far as things that it might help with, or delivery mechanisms, or anything like that? Is there anything coming down the pipeline that you think would be cool for my listeners to know about?
Well, so I'll little spoiler alert, right? With the teacrine and the wasabi and the cuprous niacin, we're doing a in vitro study on human liver cells, and we're looking at it more from a cellular resiliency, autophagy. We're also some of those legacy markers, so we're looking at cellular NAD+ levels. And so that's done. That study was a contract through Compound Solutions. We're currently disentangling that data. In terms of other stuff, Matt, do y'all have anything in the hopper?
Of course. And what we think is like more big picture on longevity. I mean, it was on the front of The Economist a couple of weeks ago. They said living to 120, it's arguably the most influential magazine in the world. So, this is not going anywhere. And we don't think it's just like settled on NAD3, because we're going to keep going, right? Because we will do that. But I think it's all these other pillars of aging. Now we have 12. So it seems silly that something like boosting NAD+ could be the one key when we have 12 pillars of aging. So if you look at like dysbiosis, for example, we're always talking about autophagy. We're always talking about senescence. We're talking about like methylation status, et cetera, et cetera. But the 12th is now dysbiosis. So how in the world does the gut interact with, insulin sensitivity, for example, or mitochondrial function, which is obviously super correlated to aging? So I think the answer to the question is, yes, we'll keep studying NAD3, but we'll also be looking at combinations thereof.
Yeah, I actually just did a pretty interesting podcast. It came out a few days ago with Colleen Cutcliffe, who makes an Akkermansia-based product. We talked about the gut metabolism axis and the gut-brain axis. And yeah, it is pretty interesting how we're seeing amongst the many dozen or so pathways of aging that dysbiosis plays a pretty significant role. Which obviously, again, when you look at functional medicine, and they often begin to treat disease in the gut or in the mouth or in the colon, the small intestine, the stomach, et cetera, kind of makes sense. So there's another person I interviewed named Sandra Kaufman, who kind of like rank prioritizes different supplements based on staving off the degradation of some of these pathways. And I think NAD plays a pretty significant role in her book as well. Although it's interesting, I think the top of the totem pole based on all of her clusters of factors and research, I think it was like astaxanthin, which is like a pretty potent antioxidant. So it's really interesting. I just love to keep my finger on the pulse of all this. And, obviously, and I've said this before on podcasts, NAD is kind of like near the top of the totem pole for me, not only because I live a pretty hard charging lifestyle and I'm on planes and, often sleeping less than I'd like to, et cetera. And, hence my NAD creatine stack that I favor, but I just feel good when I use this stuff. And this cell regen seems pretty well formulated. Anything else you guys want to share in the last couple of minutes as far as NAD or anything else that you found or you think is important to know?
We've sort of talked about this, so I hopefully don't sound like a broken record, but I am intrigued with aging and NAD. And I heard a really good friend who's also a researcher, he said, at some point in your career, Mike, research is going to become me search, right? And I'm now 42. I'll go and exercise, but things ache a little bit more. So a little bit more heightened inflammation after the fact. And I just don't recover as well. So I've been intrigued with aging. I think we hit a lot of high points, which is clearly this metabolite NAD+. There's a lot of solid ground to suggest that, hey, man, it's going down with aging. I'm also interested in cellular senescence. Personally, I think that's sort of a big area of research that's starting to pop out. So like Nathan Labrassiere, he's doing a lot of good work with Davis England there at over in Mayo Clinic with skeletal muscle specifically. But is our senescent cells hanging around in the tissue? Are they really causing a lot of havoc, and are they blunting exercise adaptations? Are they causing anabolic resistance, for instance, as well, because they're secreting pro-inflammatory cytokines in the tissue? So that, to me, is what gets me really excited. And Matt hit on that, right? Like, I mean, we're seeing anti-inflammatory effects with teocrine. Not only us, but a lot of literature out there published to date has shown that. So there's a lot of integration between my own interests and Matt's interests, where we'll continue to pursue some mechanisms.
Cool.
Yeah, and I'd say simply melding cellular and, let's call it, chemical to make a better, healthy aging. In other words, starting with autophagy and mitophagy and, how to get rid of these, how to make nice copies for cell renewal so they don't become senescent, right?
Yeah.
Like starting there and adding in, things like NAD3 and other exercise and things of this sort, I think is a cocktail, I think is the big picture that I think you have been explained, on innumerable occasions and your guests. And I just want to reiterate a cocktail versus a singular ingredient or thing.
Yeah. I think that was a big takeaway from that massive article I released a few weeks ago on NAD. I know a few people, I think that you were involved with, Matt, helped contribute to that article. I'll link to if you go to bengreenfieldlife.com/ingredients, because I get deep into sauna practices and fermented food and some of the exercise protocols that Mike was talking about, the ins and outs of this cell regen stuff, NAD3, and a lot more. So if you want like that deep, nerdy propeller hat scientific dive, also check out that article. And from what I understand, you can even get AI or GPT or whatever these days to read it to you. So you don't have to read it. So bengreenfieldlife.com/ingredients is where I'll link to that. Mike and Matt, I'll link to all your stuff as well. And I think I've got a discount code somewhere for the cell regen from BioStack, which I've been stacking along with the Cell Shield, which we don't really have time to go into now, but I think it's a pretty good 1-2 combo in my pantry. And I'll link to all that at bengreenfieldlife.com/ingredients. Hey guys, this has been fun. Super insightful. Thanks for fielding all my dumb questions about NAD.
You're good. Hey, man, can I get one shout out here? My wife, Ben, she loves you. Actually, I told Matt this before I signed on. So I was doing a postdoc in Missouri. We met there. She's a lawyer, super smart. Driving back to see her folks in Kansas City, listened to a podcast, and she's like, "Have you heard this guy?" I'm like, "No, who is this?" This is back in 2011. Ben Greenfield. I'm like, "Oh, okay, cool."
2011, jeez.
Yeah, Kristen Roberts, my wife. Fan, so.
That's awesome. Way back in the day, old school. Dude, that's awesome. All right, well, cool. I'll link to that 2011 podcast in the show notes as well for people who want to hear my high-pitched, zit-pocked teenage voice podcasting. No, I'm joking. I'm actually almost 42 myself, Mike. So thanks for the warning on the post-exercise soreness. I'll be ready for it. All right, guys. Well, thanks so much, folks. This has been Mike Roberts and Matt Titlow I've been talking to, along with me, Ben Greenfield. Signing out from bengreenfieldlife.com. Again, show notes are bengreenfieldlife.com/ingredients, so you can take a deeper dive into all these fantastic ingredients for upping your own NAD and keeping it from being depleted. All right, Mike and Matt, I'll talk to you later, guys.